This is related to the general idea of what's called locality-sensitive hashing. All right? So I'm going to assume that most of you as computer science students, you know what hash tables are and what hash functions are. And if you don't, you may not understand this. Normally, a hash function maps some data structure into some nicely distributed space. So you might have a function that maps structure to the integers between 1 to 100. Okay? And you can think of those integers as bins. So if you give me some new data structure and I want to know, have I already seen one of these before, I map it through that function and I go and I look at the bin and I only search through the ones that are in that bin. Okay? So if it's distributed kind of evenly, you're going to reduce your search work by a factor of 100. Right? Because you apply this function and you reduce it down. But the problem with the design of hash functions is that they are very precise. They're designed for precise data structures. Locality-sensitive hashing works similarly, but it's a little bit different because it takes the notion of distance into account. And the basic idea is you're going to construct some hash function. Here it's written as g, okay, and it's going to map onto some output u. All right, and the idea is, and there's some like Greek written here, etc. But the basic idea is that if you have 2 points that are nearby in the original space by some distance measure, then the probability that those 2 points will land in the same bin should be pretty high. Likewise, if I've got 2 other points that are far away in the original space, the likelihood that they land in the same bin should be relatively low. Okay? That's what locality-sensitive hashing is. And when you do that, it means that I can compute this hash function, go to whatever bin it sends me, and the idea is that descriptors that were similar, not exactly the same, but similar, will be in the same bin. There was some nice work done by Kulis and Grauman. The title is Kernelized Locality-Sensitive Hashing for Scalable Image Search. There's a lot of work on kernel functions. We'll talk about them later. This is not the kernel of a filter. Sorry, they use the same name. But the kernel functions here are a way of mapping from some dimension to some higher dimension and then operating on them. And this is an approach of how to do applying these kernels to SIFT features. What's important is it's a nice discussion in there about doing this locality-sensitive hashing.